Hey everyone, welcome to InsightsByRish. In today's video, I am going to demonstrate how we can perform regression using neural network. And for this, I am going to make use of this car price prediction dataset. I will provide the link of this dataset in the description box. So here the main motto is to predict the car price, which is continuous in nature. And we are going to do this with the help of neural network. So let's start implementing this. So starting with, I have already loaded this CSV file in my Google Colab environment. And here we will start implementing it now. So first we will start with loading the data here. So let me just say here, loading the data. So first we require the necessary libraries here. So let me just say import pandas as PD, and the remaining libraries we will import as per the requirement. So let's run that for now. And here we will load the data set. So pd.read CSV, and here we will pass the path of CSV file. Let's run that. Now let's check the dimension of this data frame. So this file consists of 205 rows and 26 columns. I can even display it for you here. So these are all the columns that we have in our data set, and the last column, which is the target column for us, and that is price, that we are going to predict using the neural network here. Also, you can see that this price column is continuous in nature, which means we are performing regression task here. So we are done with loading the data. Second, we will start with data preprocessing here. So let me just say data preprocessing. Now in this stage, first we have to drop the unwanted columns here. So let me just say dropping the unwanted columns. So by taking a look at this data set, we can say that we don't require certain columns here, and those are car ID and symbolic. We don't require them in any aspect. So we are going to drop them. So let's just say here df.drop columns is equal to, and we will supply the names of columns here. So car ID, and the second one is symbolic. And here we will say in place is equal to true in order to make those changes permanent. Let's run that. It's actually drop and not crop. So here, let me just display the data frame again. So as you can see, now we don't have that unwanted columns anymore. The next task that we have to do in this data preprocessing step itself is checking the null values. So let me just say here, checking the null values. So here we will say df.isNA.sum, which will display us the count of null values from all the columns. So everywhere we just have 0, which means we don't have null values in any of the available columns. So we are done with this. The next task that we want to do is, now we will divide our data frame into two parts, the input features and the target feature. So let's just say here, dividing the data frame. So we will have two elements here, the first one being capital X and the second one being small y. In the capital X, we will have all the input features up till the second last column here, which is highway. And in the Y, we will have the target feature, that is price. So let's just say here df.drop columns equal to price. So instead of manually including all the columns from beginning up till the second last, we are just doing that in a shortcut way. We are just dropping the price column, which means all other columns will get included eventually. And then here in Y, we will have the price column. So let me just say df price. Let's run that. And let me just show you the columns from this X here. So as you can see, now we don't have that price column anymore in the input data frame feature. So this X consists of all our input features, and this Y consists of our target feature. Now you might notice that we don't have all our input features just in numeric format. We have them in a mixed format. We have some categorical values and some numerical values. But we want that all our input features should be mandatorily in numerical format. And hence the next task that we are going to perform here is converting the categorical data into numeric one. So for that, First thing that we are going to do is we will create a list that will include names of all the columns which are categorical in nature. So let's just say here categorical columns, this is the list, and here we will say df dot, we will use an inbuilt method here which is select d types. This will help us to select the data types, basically the columns with some certain data types, and here we will say include. Now here we have to specify the data type for which the columns we want to include. So here I will say object, that is I want to include all the columns that have object data type. Naturally in any machine learning data set, the categorical columns have object as their data type. So here then I will say columns because I just want the column names, and then I will put that into a list, so to list. Let's run that. It's actually select data types. Now let me just display this categorical columns list to you. So as you can see, these are all the columns which are categorical in our data frame. You can even see that here. So car name, then car body, door number, all these columns are categorical in nature, and we have extracted them now in our categorical columns list. The next thing that we are going to do is to convert them into numerical format using getDummies function from pandas. So here I will say categorical data frame is equal to, here I will say pd.getDummies, and then we will say here df. Then we have to pass this categorical columns list so that all the columns that are categorical in nature from this particular data frame will be extracted, and let's run that for now. Now let's visualize how this data frame looks like. So if you see, right now the data values here are in Boolean format, that is true or false, but we want them in integer format, and hence while writing this code we have to explicitly convert these values into integer data type. So here I will just say as type int. This will help us to explicitly convert this all data values into integer format, and now they will be no more in Boolean format. So let's run that again. So now as you can see, we have all these values in a combination of zeros and ones, and they are mainly in integer format. So now after doing that, let's now delete the existing categorical columns from the previous data frame, that is this one. In this TF we had some columns of categorical nature, now we have to delete them. So here I will just say deleting original categorical columns. And also be mindful about one thing, and that is we are not deleting these columns from the main data frame, that is df. We are deleting it from x. X is the data frame in which we have all our input features, and whatever operations that we are performing furthermore are on this data frame x and not on the previous data frame df. So here I will just say x dot drop columns is equal to, and here we will directly pass that categorical columns list. So all those categorical columns from the x data frame will be deleted now, and also we don't require the square bracket here, we just have to pass the list because it's already in the square brackets. And then we will say in place is equal to true in order to make those changes permanent. Let's run that. Now let me just display this data frame to you. So as you can see, now in this X data frame, which consists of all input features, we have all the numerical data and all the categorical columns that we have deleted, but the numerical columns that we generated out of those categorical columns are now present in this categorical data frame. So the next thing that we want to do is we have to concatenate this categorical data frame and this X data frame. So let's just do that. So here I will say concatenating the encoded columns with X. So here I will just say X. This is a new data frame with the same name X. Here I will make use of concat method from pandas, and in this we have to pass a list of data frames that we want to concatenate. So first I will pass the X, that is this particular data frame, and secondly we will pass the categorical data frame, that is this one. Now after concatenating it, we also have to specify that on what basis we are concatenating, whether we are concatenating it on the basis of columns or on the basis of rows. So here we are concatenating it on the basis of columns, and hence the access is 1. Let's run that. And let me display this X to you now. So as you can see, now those encoded columns have successfully been concatenated in this existing X data frame. Now we are done with this. The next thing that we want to do here is data normalization. So let me just say here, data normalization. It's necessary to normalize your data, and there are various methods to perform normalization like min-max scalar, standard scalar, but we are going to go ahead with the min-max scalar method here. So for that we require min-max scalar module from scikit-learn, and let's import that. So here I will say from sklearn dot preprocessing import min-max scalar. Let's run that. Now coming back to this cell, here we have to create an instance for that min-max scale module. So let me just name it as scalar, and I will load that min-max scalar module here. Now after loading that, we have to make use of fit_transform method here, which does both the work in a single go. That is, it also fits the scalar module onto your data, and it also transforms the value. So here I will say X, then a square bracket and a colon. I will let you know the significance of this in a minute. So here I will say scalar dot fit_transform, and in this we will pass our X. Now this X is our existing data frame. As you know, this is the existing data frame that we have, and we are passing it here in the fit_transform method, and this X is a new data frame that we are creating again with the same name. Now the significance of this colon and the square bracket is, if you don't give this square bracket and colon, then all your transformed data will get stored in array format and not in the data frame format. But we want that our transformed data should directly get stored in a data frame format, and hence we are passing this square bracket and colon. Let's run that for now, and let me display this X again. So now you can see, initially this data frame was not normalized. As you can see, the values of different columns are on different scale, but now the X data frame is normalized, which means all the values of all the columns lies between the range of 0 to 1. Now this data normalization was the last stage of data pre-processing part. The third stage now in this video is train test split. So let me just write here, train test split. So for this we require the train test split module from scikit-learn again. So let me just import that here. I will say from sklearn dot model selection, I will import the train test split. Let's run that. Now coming back to this cell, here let's perform the train test split. So here I will say xtrain, then xtest, then ytrain and ytest. Now here we will call that train test split module. So train test split, and in this we will pass our input data frame, that is X, which consists of all our input features, and now it's also normalized, and then Y, which consists of just our target feature, that is price. Then we have to give the test size. So let's give this test size as 0.2, which means 80% of the data will be stored in the training and 20% of the data will be stored in testing set. And then random state is equal to 42 for better reproducibility. Let's run that for now. Now after performing this train test split, we are moving ahead to the main core part of this video, and that is building a neural network model for the regression task. So let me just say here, building, just a minute, neural network for regression. So for this we require TensorFlow, and let me just import that first. So going back here, I will say import TensorFlow as TF. Let's run that. Now coming back to this cell, here we will say model is equal to, and we will start building a sequential module from Keras. Now this Keras is present inside this TensorFlow, and hence we will say TF, which is an alias given to TensorFlow.Keras, and in this Keras we have sequential module. So this sequential module will help us to implement all the layers from this model in a sequential manner. The first layer that we are giving inside this sequential module is the input layer plus the first hidden layer. So here I will say input layer plus the hidden layer. So here we will say tf.keras.layers, and this will be a dense layer. So dense. Now here first we have to specify the number of neurons that we will have in this layer. So let's say that we will have 300 neurons. You can give anything. This is just a hyperparameter. You can have any number of neurons in your hidden layers, but I will be giving 300 in the first hidden layer. And then we have to specify the input shape here. Now this input shape, what input shape should we give? So if you just check the shape of this X-train here, let me just say X-train dot shape. Just a minute. So you can see we have 198 columns here, and even here you can see we have 198 columns. That is starting from the first column up till the end, we have 198 columns in the data frame, and hence our input shape will be 198. That is, we are passing the 198 columns entirely to our neural network model. So 198, and as you know, in Python a tuple cannot just have a single element, hence we have to trail it with a comma. Now after doing that, here we have to specify the activation function, and always the activation function for any kind of hidden layer is ReLU. So this was the first dense layer which does both the work. It is also an input layer and it also is a hidden layer. Now after doing that, we will have second hidden layer here. So let me just say second hidden layer. Again this will be a dense layer. So here I will say tf.keras.layers.dense. Now in the second hidden layer, again you can have any number of neurons, but I will have 150, and then again activation function which is ReLU. Now we just have to specify this input shape in the first layer itself and not in the upcoming layers. So this was the second hidden layer. Let's add one more hidden layer here, which is third hidden layer. So we'll again say tf.keras.layers.dense, and in this third hidden layer, let's say we will have 75 neurons, and the activation function will again be ReLU. So these are the three hidden layers that we are having in this neural network. You can have any number of neural network layers in your model depending upon the complexity of your project. Now we will add the final output layer here. So output layer is again a dense layer. So here we will say keras.layers, actually tensorflow.keras, and then dense. Now the output layer will just consist of a single neuron, because as you know, in regression task we are having continuous values. Like if it's a classification problem, if it's binary classification, then we give our output neuron as 1, and if it's multi-class classification, then we give our output neurons equal to the number of classes that we have in our original data frame. But here, while performing the regression task, we have to specify just a single neuron in the output layer, because that single layer can give any value out of those continuous values. And we won't have any activation function here in the output layer. Typically, when we are performing any kind of classification task, like if it's binary classification, we give the activation function as sigmoid. And if it's multi-class classification task, then we give the activation function in the output layer as softmax. But while performing regression, we don't have to specify any activation function in the output layer. It will just consist of one output neuron. So we are done with this. Let's run that. So this was the model that we built for our regression task. Now after doing that, let's perform the compilation here. So compilation. So here we will say model.compile. First we have to specify the optimizer. So let the optimizer be Adam. After that we have to specify the loss function here. So typically in classification problem, we specify the loss function as binary cross entropy or sparse categorical cross entropy. But in regression, we have to specify it either as mean absolute error or mean squared error. So I will specify it as mean squared error. And after that, we will specify the metrics, that is on what basis we are evaluating our model. So here we will specify the mean absolute error. In classification task, here we specify the accuracy, but in regression task, here we will specify one of the loss function. Either if we are giving the loss function as mean absolute error, then we have to specify the metrics as mean squared error, and vice versa. Let's run that. Now let's fit our model. So here I will say model.fit, and in this we will pass our training set, that is xtrain, just a minute, and ytrain. Then we have to specify the number of epochs. Again, this is a hyperparameter. You can specify any number of epochs. I will specify it as 50, and then the batch size. So this basically means that you are not passing all your rows individually, but rather you are passing it in a group, or you can say it in a batch. And let the batch size be 3, which means in every epoch, or we can say in every iteration of epoch, we are simultaneously passing 3 rows, or we can say 3 data values as a batch. So let's run that. So as you can see, this training has started and it's very quick. This is because we have very less number of rows in our data set. It might take a long if you have a very large data set. And here it will display you the loss depending upon the mean squared error, and it will also display you the mean absolute error. With every epoch, the mean absolute error reduces, and this is what we want. The mean absolute error shouldn't increase, but rather it should decrease. Now, after compiling this model and after training this model, the next task that we have to do is prediction and evaluation. So I think this was the 4th stage of the project, and now we will move ahead to the 5th stage here. So let's name this stage as prediction and evaluation. For evaluation, we require some predicted data as well, and hence we are first performing the prediction. So here I will say pred is equal to model.predict, and in this I will pass the x test. Let's run that. Let me display you these predicted values. So as you can see, this is an array of predicted values that you have, and right now they are in 2D. We have to reshape them in 1D. So here I will just say pred is equal to pred.reshape -1. Let's run that again. And here let me again display this spread now after reshaping. So now it's in 1D array. Now let's say that we want to compare our predicted results with the actual ones. That is, we want to create a new data frame that will just hold actual values and the predicted values so that we can compare them side by side. So let's do that. So let me just display the y-test to you for now. So this is the y-test that we have, and what we will do here is, let me say, convert y-test to a data frame and reset the index. Now that's already in the data frame format, I know, but the index is not sequentially, so we have to reset this index as well, and hence we will do that here. Here I will say y-test is equal to pd.dataframe. Here we will again pass the y-test, and here we will make use of reset index method, and drop is equal to true. Let's run that, and let me again display you the y-test. It's actually reset. I missed an E here. Let's run that again. Fine. Now let me display this y-test. So now we have the index in the proper format. The next thing that we want to do is, now we will convert the predictions in the data frame format. So let me just say here, convert predictions in data frame. As you can see, right now the predictions are in array format, and we want to now convert it into data frame format. So going back to this cell, here I will just say prediction data frame is equal to pd.dataframe. Then we will pass this predictions here, and then we will say columns. That is, we want to give the column name here, and let's name this column as predicted. Let's run that for now, and let me display this data frame to you. So as you can see, this is our predicted data frame now. The next thing that we want to do here is, now we want to concatenate both these data frames into a single one in order to compare. So let's name this data frame as compare data frame, as we are comparing the data values here. And here I will say pd.concat. This concatenation will only happen if the length of predicted data frame is equal to the length of original y-test data frame. So if you can see, in the y-test we have the 40 instances, and even in prediction we have 40 instances. If in case you have different instances in both the data frames by chance due to some error in the earlier code, then it won't work. So let me just pass this whitelist and then the pre data frame here. And as we are concatenating it on the basis of columns, here I will say access is equal to 1. And let's also give column names to the columns of this data frame explicitly. So let me just say here compare data frame dot columns is equal to, for the first column we will give the name as actual, and for the second column we will give the name as predicted. Let's run that. Let me show you this data frame now. I will just display the first 5 rows. So as you can see, this is the actual values that you have on the left column and the predicted values that you have on the right hand side column, and they are close to the actual values. So the predicted values are significantly close to the actual ones. There is some slight difference here and there. To visualize this more accurately, we will try to plot this using the matplotlib library. So let me just import that first. Going to this cell, here I will import matplotlib. So import matplotlib.pyplot as plt. Let's run that. Now coming back to this cell, here I will just set the figure size first. Here I will say plt.rcparams. Here I will give the figure size. So figure.figsize is equal to, let's give this as 15,4. Again, this is just based on trial and error. You can give any figure size as you want. Then we will plot. First we will plot the actual data plot, and secondly we will plot the predicted data values. So here I will say plt.plot. Then let me give this data frame name, which is compare.df, and from that the column named as actual, which consists of all actual values. After that we will give the color here. So let the color be red, that is all the data values that are actual in nature will have red color, and then we will give the label, that is actual. So this was the first line plot. This plot method from matplotlib basically plots the line plot. And just a minute, it's compare. After that, similarly we will plot one more line plot here, and that will be for predicted value. So the second column that we have here, predicted, that we have to pass here in the second line plot, and let the color for the predicted values be blue, and the label is predicted. So predicted. So this was the second line plot. Now the next thing that we want to do here is we will give some title to this plot. So let me just say plt.title, and let the title be comparing actual versus predicted values. After this title, we will give the x label and y label, that is the label that we will have on x-axis. It will be the index, that is on x-axis we have all the indexes, and plt.y label, it will show the label on y-axis. So let the y label be prices, that is on y-axis we will have all the prices. And after that, to display these labels that we have given here inside the line plot, we have to just say here plt.legend, so that the legends will be displayed. Let's run that. So as you can see, this blue line represents your predicted values and the red line represents your actual values. So on some places this blue line overlaps the red line, which means on some places the predicted values are very close to the actual ones, and somewhere there is slight differences, but overall you can see that the predicted values are very close to the actual ones. So this is how you can perform a regression task using neural network. In this video we saw how we can build a neural network to perform any kind of regression task. I will provide this code file and the dataset that is present on my GitHub repository in the description box. Do check that. So that's it for the video. Thanks for watching.